The Geometry of Change. Living Numbers. Book 2. Written and narrated by Santiago Machain. Chapter 1. Why model? Modeling begins with a deceptively simple impulse: to make sense of the world well enough to act within it. Whether we are designing a bridge, forecasting a market, diagnosing a disease, or interpreting a social trend, we construct representations of reality that help us reason, decide, and communicate. A model is not the world. It is a deliberately crafted simplification that captures essential features of a phenomenon in a form we can interrogate. The value of a model lies neither in its elegance nor its complexity, but in how it changes what we can see, anticipate, and do. Although modeling is often associated with mathematics and computation, its roots are older and broader. Humans have always modeled, through stories, maps, diagrams, metaphors, and mental routines. Modern models add rigor and accountability, yet the core impulse remains. We model because reality is unwieldy and action is finite. To understand why modeling matters, it helps to disentangle three intertwined threads: models, mechanisms, and measurement. Models give shape to our hypotheses. Mechanisms give those hypotheses a spine, explaining why cause might yield effect. Measurement, meanwhile, anchors both in observable traces, enabling us to test, refine, and trust what we have built. When these three align, good decisions become repeatable rather than lucky. When they drift apart, we risk mistaking correlation for causation, overfitting to noise, or failing to notice when the world has changed. The craft of modeling lives in managing those alignments, knowing when to zoom in on mechanism, when to expand the scope of measurement, and when to revise the structure of the model itself. From description to decision. At its most basic, a model describes. It organizes observations into categories, curves, or narratives that reduce complexity. Description is valuable in its own right, especially when we confront phenomena too large or subtle to grasp directly. However, the underlying reason to model is not merely to compress information, but to aid decision-making. A decision demands that we prefer some actions over others under uncertainty. Models convert nebulous uncertainty into structured risk, and structured risk into trade-offs we can evaluate. Importantly, a model can be useful even when it is wrong in detail. The phrase, "all models are wrong, but some are useful," endures because it captures a pragmatic truth. Accuracy is not a binary, it is contextual. A model that crudely classifies patients by risk may still triage resources better than a queue. A simple representation of traffic may still guide the placement of signals more effectively than intuition. Decision value emerges from whether a model's errors are tolerable relative to the stakes, the timing, and the alternatives. In this way, modeling is inseparable from judgment about consequences. As decisions grow more complex, the purpose of modeling deepens. We model not just to pick an action, but to understand how the system might respond after we act, how incentives might shift, and how feedback loops might amplify or dampen effects. We do so to anticipate unintended consequences, manage interdependencies, and prepare adaptive strategies. Thus, when we ask, "Why model?" we are also asking, how will this model change what we watch for, whom we involve, and how we learn as we go? Abstraction as a design choice. Every model begins with abstraction. The choice of what to include, what to exclude, and what to treat as exogenous. These choices are design decisions, not mere technicalities. They reflect values and assumptions about causality, agency, and scale. A financial risk model that treats human behavior as noise will produce different insights than one that treats it as signal. An ecological model that abstracts away seasonal variation will perform differently than one that embeds it as a primary driver. Abstraction has costs and benefits. Too much fidelity can drown signal in detail, undermining generalization.
Sample complete. Ready to continue?